Welcome back. Here we go, section 3.3. We're looking at variables on both sides. The target today, I can solve equations with variables on both sides of the equal sign. Okay, we're going to go over kind of a generic way and strategy to solve linear equations. That's really what we're working with. Everything that we see here is a linear equation. So step one, use the distributive property to remove any grouping symbols. And so that's if you have a number outside of a set of parentheses that's being multiplied by that parenthesis expression. So we want to get rid of that. Step two, simplify the expression on each side of the equation. And that's kind of that thing we talked about last section on combining like terms and then solving. Step three, use the properties of equality to collect variable terms on one side of the equation and the constant terms on the other side. Okay, and that's really what we're going to be looking at today. So we'll go ahead and pick up with this example right here because there are no grouping symbols, so we don't have to use distributive property on either side. Each side only has an x term and a constant term, okay, x and constant. And then what we're going to be doing here is collecting the variables on one side. Now, if you remember a while ago, and maybe you still use this idea of having the vertical line being kind of the wall, I think of it as the Great Wall of China. And in order to move across that wall, you have to do that operation to both sides. Okay. One thing that I focus on is I always focus on taking the smallest x term. Okay, this one is 3x's, this one's 5x's. 3 is smaller than 5. So to move that, usually when we have something on an x, we want to divide it or multiply it or whatever we have to do to peel that number away from that x. We're not going to do that yet. I'm going to move this 3x to the other side. The way I move it to the other side is I'm going to subtract it from both sides. Okay? So we're subtracting that 3x from both sides. So it cancels out over here, and now it gets placed onto this side. And since it has a like term with it, I'm going to go ahead and just simplify that, combine those like terms. 5 minus 3 is 2x. Plus 15 equals negative 15. Yeah, that equal sign, that goes through that Great Wall of China. Now it just looks like a two-step equation, something we did last section. That's why solving equations is so awesome. All you're doing is turning any problem into something you've already seen. So I'm going to subtract 15 on both sides. I have 2x equals negative 15 minus 15 is negative 30. And then divide by 2. Divide by 2. All right. Those 2's cancel out. That's a one-step equation. And negative 30 divided by 2 is negative 15. Okay, that's pretty awesome. I took a really complicated looking problem, turned it into something that I've seen before, and then solved what I've seen before. Okay, it kind of works out pretty well. So that's the big thing. I'm sure we did it, but we'll just go over step 4 and 5 here. Use the properties of equality to solve for the variable, and then check your solution in the original equation. It's always a good idea to check your work. So let's say that I think negative 15 is the answer. We can plug that in for x. Okay, plus 15. And the other side would say 3 times negative 15 minus 15. Okay, 5 times 15 or 5 times negative 15. You can grab a calculator if you need to. I'm going to just so that I make sure we get this stuff right. And I get negative 75 plus 15 equals, excuse me, 3 times negative 15, that's negative 45, and minus 15. When I'm checking my work, I should end up with the same number on both sides, because that's what a solution to a linear equation is it's the number for x that makes each side equal to the other side. So negative 75 plus 15 That's going to give us a negative 60. And negative 45, go back 15 more, is also negative 60. So we get negative 60 equals negative 60. That's what we needed to have. Okay, and that's just a good thing to do every once in a while, is to check your answer. Okay, sometimes I may require it, sometimes I may not. All right, but that's my check on that work. Let's go ahead and look at some of our examples down here, and let's make sure we go through all 5 steps of solving an equation. Okay, and I'm even going to put here all 5 steps to make sure that, we also go back and check our work, make sure that our answer fits. All right. For this first one here, we have 2x minus 4 equals 12x minus 14. Okay. Remember, I am going to always move the smaller one. Okay. I'm going to move that 2x. So I'll subtract 2x, bam, bam. Those cancel. I have negative 4 equals 12 minus 2 is 10. X's minus 14. I'll add the 14 to both sides. Okay. At this step, it is a 2-step equation. Okay. Subtracting that 14 adding that 14 gets rid of that. And negative 4 plus 14, that's going to be a positive 10. Equals 10x. Divide by 10, you can kind of see where this is going. Okay. But x equals 1. Okay. The answer comes out as 1 equals x. If you want to rewrite that as x equals 1, that's okay. The original one's okay also. Don't think that you have to change that. It's not necessary. But some people just really like that. I know I like having the variable first. It just helps me see it a little bit better. Now let's go back and check through that real quick. So I had 2x, so 2 times 1 minus 4 equals 12 times 1 minus 14. 2 times 1 is 2 minus 4. 12 times 1 is 12 minus 14. 2 minus 4 is negative 2. 12 minus 14 is negative 2. Okay, negative 2 equals negative 2. Life is good. All right, let's keep going. So this one we do have grouping symbols to take care of. So I know in the past, I've divided this. Divided both sides by 2 first. You can do that, but sometimes it's going to get ugly and it's going to give you a fraction. A fraction on your x term on the other side. You don't really want to do that. So I'm going to distribute first. If I distribute, usually my numbers are going to get a little bit bigger, but I'll make sure that I have whole numbers by doing that. All right. So I get 2x minus 8 out of that distributive property step. Now it looks just like the problem I just did. Okay, I'm going to go ahead and move the smaller one. Well, which one's the smaller one? They're both 2. Well, not quite. This one is a negative 2. So the beauty here is by moving the smaller one, I always end up with a variable term that's positive. Okay, as long as, well, no matter what, really, we're going to get a positive variable term here. Okay, so we get 4x, 2 plus 2 is 4, minus 8 equals negative 10. So I will add 8 to both sides, add 8 to both sides. Okay, those 8s cancel. I get 4x equals negative 2. Okay, 4x equals negative 2. I'll divide by 4, and it shows 2 over 4. We can probably see that that's going to be a negative 1/2. Negative 1 over 2, just negative 1/2. Let's go ahead and do a quick check here. Let's throw in negative 1/2, negative 1/2. Okay. Negative 1/2 minus 4, that's going to be negative 4.5 times 2. So let's see here. Negative 0.5 minus 4. Okay, yeah, negative 4.5 times 2 is going to give us negative 9. Okay, I'm trying to do my check, and you can do this also. I'm doing my check without really taking a whole nother side, mainly because I don't have a whole lot of room over there. I don't want it to get confusing. Okay. All right, so I get negative 9 on that side. Let's see what I get over here. Negative 2 times negative 1/2, that's going to be a 1, positive 1. All right, positive 1 minus 10 is negative 9 over there. Okay, we are good to go. All right, let's move on to the bottom two. If you want to, and I think it's a good idea, go ahead and pause those and give it a shot. Pause that video, give these two problems a try, and we'll be back to check the answers. Go. All right, welcome back. Hopefully you got those answers done and you checked them and everything's good to go. All right, I'm going to move the smaller one. Hopefully you did too. It just makes life easier. Yeah, I don't like dividing by a negative very often. Yeah, that makes weird stuff happen at times, and I just don't like negatives. All right, so 8 minus 3, that's 5x minus 8. Add 8 to both sides. And we get those cancel out, of course. 5x there and 20 there. Divide by 5, and we get x equals 4. Okay, or 4 equals x. Let's go ahead and box that answer. And we'll check it over here. We'll go ahead and plug it all in. So 3 times 4 plus 12 equals 8 times 4 minus 8. 3 times 4 is 12, plus 12 equals 8 times 4, 32, minus 8. 12 times 12 is 24. 32 minus 8, 24. We're good to go. Okay. Throw that check mark on there. Tell yourself you're good. X is 4. It worked. All right. This one, wow, that's ugly. Let's go ahead and get rid of some of these parentheses in here, because remember, I don't really like those. At the same time, I have like terms over on this side. I'm going to go ahead and combine those. All right. So combining steps, sometimes if you can handle it, it makes life pretty good. 80 minus 30. 8 minus 3 is 5, so 80 minus 30 is 50n. Here I have a distributive property. Negative 10 times 2 is negative 20. Negative 10 times 5 is positive 50. And that term has an n on it. Okay. Over here I have a negative 1. Even though there's not a 1 there, it is a negative 1. Okay. Distributing a negative. So that's going to be a negative n and a plus 1. I have like terms over here. I'll go ahead and combine those. I have the n's and I have the constants. The ones without variables we call constants. Okay. And let's see here. We have that's negative 20 plus 1. I'm going to go ahead and write that as a negative 19. A 50 minus 1, that's going to be a positive 49n. Okay, now I have no more like terms except for on both sides of the equation. I'm going to go ahead and subtract that 49n. Ugh, that's ugly. You get it though. Minus 49n. And we'll subtract those away, get rid of that. The right-hand side, we're just left with negative 19. That's cool. Oh, and look what worked out here. 50 minus 49 is 1. There's only one n there. There's no dividing, no multiplying, nothing else to do to find n. Okay, the only thing we have left to do is check it. Okay, I'm going to go ahead and use this second step because nothing's really different here. All I did is distributive property, and I trust myself that far. So I have 50 times negative 19 equals, and we have like terms there. I guess I'm gonna use this step here because that's where my work kind of from previous got over with. So I have a negative 19 and plus, not a parentheses, yes, yet, plus 49 times negative 19. Okay, getting a little ugly and smashed in there on the end, but that's okay. Okay, just keep yourself focused on what you're doing. Well, let's use a calculator on this. The numbers are getting a little big. 50 times negative 19, negative 950. Negative 950 equals, we'll leave that negative 19 there. And we'll go 49 times negative 19. That's a negative 931. That's a plus negative 931. Okay. We'll take that negative 931 and add on a negative 19, and we get negative 950. So negative 950 equals negative 950. Again, numbers got a little big. Don't worry about it. Okay, life goes on. All right, go ahead and turn the page, and we'll see what's coming up next. Okay, this is the cool thing here. Crazy stuff can happen. All right, as always with life, crazy stuff can happen. So when we start off here, it kind of has a little definition here. It says when every number is a solution to the equation is called an identity. All right. These can be found when both sides of the equation equal each other. So something's going on, you're solving, and you come into a point where you get something like, and this is just when you're solving, not when you're checking your work, that's different. But when you're solving, you get something, maybe it says 7 times 7. Okay, well that's weird. All right, 7 always equals 7. We call that the identity. Okay, and in an identity, you may remember it's something where it has infinitely many solutions. And basically what that's saying is no matter what number you plug in for x, the equation's going to work out. Okay, so most problems that we come across only have one equation. Since they're linear equations, there's only one equation. Okay, but there are times where we get infinitely many solutions, and those are just things we have to look out for. Okay. The other side of the coin is if no number exists that is a solution to the equation, we say that equation has no solution. Okay. There's actually another word for it. It's a contradiction. Okay. It has no solution. These can be found when all of the variables cancel and only 2 different numbers are left, and those 2 numbers are set equal to each other. That might look like something like, oh, maybe 12 equals 8. Well, in no world that I know of, 12 equal 8. Okay, it doesn't happen. It gets crazy. Okay, so let's check out what these will look like once we're solving them. All right, I have 5 plus 5x, nothing to do over there. Over here, I have a little distributive property going on here. 5x plus 5, or 5 plus 5x, either way, equals 5x plus 5 times 1 is 5. Okay. Now let's go ahead, and my next step has always been to move the smaller x term over. Well, it doesn't really matter. I have 2 of them, right? They're the same thing. I can go ahead and subtract 5x minus 5x, and here we go. Those cancel. Those cancel. My variables are gone, and 5 equals 5. Well, yeah, 5 equals 5. Of course it does. We call that the identity. Okay. If you wanted to check your work, you could, but you'd be really tired of checking all the numbers that could possibly work. Okay. It doesn't matter if x is 1, 2, 3, 5,000. Okay. No matter what you plug in there, it's always going to work. Okay. Excuse me. Let's check this next one. Okay. The hint's right up here on what your answer is, but let's see what happens. This is a no solution problem, and I have distributive property on both sides. 2 times n is 2n. 2 times negative 1, negative 2. 2 times n is 2n. 2 times 3 is positive 6. Okay? So now I'm going to go ahead and subtract 2n from both sides of the equal sign. Those go away, those go away. I have negative 2 equals 6. Negative 2 doesn't equal 6 last time I checked, so that'll be a no solution. No solution. Doesn't matter what x you pick, it's not going to work. Okay? Here they all work, here none of them work. Okay? It's 2 sides of the same coin. I want you to go ahead and pause the video and try these 2. Don't get thinking that because this one is in the identity row means that it'll be an identity. It could come up with a single answer. You never know. Go ahead and give it a shot. Okay, welcome back. And here we go. We're going to go ahead and use distributive property. Boom, boom. Negative 4 times 1, negative 4. Negative 4 times 6v is negative 24v. Equals 9 minus 24v. Okay? I'm going to go ahead and add 24v to both sides. I know something's fishy because my variables have the same coefficient. Okay, since they have the same coefficient, I know something's looking ugly. I have negative 4 equals 9. Well, negative 4 does not equal 9. We know that. Since it doesn't equal, we have no solution. It doesn't matter what we plug in, it ain't going to work. All right, let's look at this one over here. So I don't have any parentheses, but I do have some like terms over here. The -8 and +7. So -1 plus 4m equals 4m. -8 plus 7 is -1. I'm going to go ahead and subtract that 4m out of there. Again, my coefficients are the same. I should know something's in the air. Okay, Mr. Gall's trying to play a trick on me here. But I have -1 equals -1. Identity. It is true. Identity. Any number is going to work in that case. Doesn't matter what it is. Okay. So that's our talk on variables on both sides. Hopefully you just see that it's just a continuation, and very quickly you can make it look like one of your other problems. Okay. So go ahead and do the practice problems, application, get all that stuff checked. And good luck on that mastery challenge. We'll see you next time. Now that we're halfway through this unit, we've had number 4, wiener dog tennis, number 3, mirror pug, and now we're on to number 2, sleeping on the stairs. I hope you enjoy. It's a pretty good one.
But that's so trying to put his head up like this and sleep. I hit. You see hit. Because no light, I just because it's running, then I think about it. So like that. What is a little bit like Charlie, but it's too high for you. Uh-oh. But I'm waiting, am I behaving?